Hello, today's lesson you're going to just type into the Frayer model what we're going over, and you're going to hand that in for the initial lesson. Alright. Alright, explain why the graph below shown represents a function. Describe the function in two other ways. So pause the video if you know what a function is, and tell us why it represents a function. All right, let's talk about some things first. A function is a type of relation. So if we look at the vocabulary for today, we're going to go over relation, function, domain, range, independent variable, and dependent variable. Why is this graph a function? Is because the definition of a function, and let's go to the definition of a function. The definition of a function is that it's a relation, and a relation is just a relationship between two data sets that pairs each input with exactly one output. All right, so for the definition part, just write this definition. Basically, in my own words, it means that an input has only one output. What I like to tell people when I'm describing this is if you think about going to a bodega, right? If I buy a bag of chips, right, like I expect to pay, the same amount. Usually it's 50 cents. But I have a bodega near my apartment where one day the same bag of chips will be 50 cents. But another day, that same bag of chips would be 75 cents. And it really bothers me. It really bothers me that it could be the same person that same bag of chips can have two different costs. And that's what, because you know why? Because to me, I'm someone who likes functions. I'm a math person. And a function says that, every time you have one input, which in this case is the bag of chips, you have the exact same output every time, which for me is 50 cents. So an output can have multiple inputs. So for example, there can be different items in the store that are 50 cents. I'm fine with that. What I have issues with is when I walk into a store and it's the same item that on one day will cost something different another day. That doesn't work for me because that's not a function, right? A function, just think of a very good store, right? A function means that, whatever item it is, it's that price no matter what all the time. So I have some pictures here of an example of a function, right? Sometimes we call a function a machine, a function machine, where you have an input, you do a rule, and then you get an output. This is a very popular function notation that we're going to go over. F of x. F stands for function. X is your input, your domain, and 2x plus 1 is the rule. The domain. So I told you that we're going to go over what domain means. What a domain is it's your input. So when you hear domain, I want you to think of what am I inputting into my function machine, right? So my domain is what I'm putting into the machine. My domain is also my x, right? So before our intro, I asked you what are the different ways you can represent a function. You can represent it as a table, an equation, and a graph. Those are the three ways in algebra that we're going to talk about functions. Your range is your output. And the range is it's what gets spit out from the function machine. It's the y, right? This is your range. All right? So that's your output. So for your homework, you're going to have to list what the domain and range of a function, and all you have to do is just look at what's in the first circle, the domain, and just list out those numbers one at a time. 0, -2, 0, 1, 2. Right? And for the range, you're just going to have to look at what's in the box and write out those numbers. 0, 1, 4. All right. All right. For example, if I have to find the domain and range of this table, all I have to do is when I'm looking at the domain, I just list out, I say domain is and I list out all the numbers on the x for this table right here. So I write -2, -1, 0, and 2, right? And then for range, I just write out all the y's. So -3, -1, 1, 3, and 5. All right, now for your Frayer model, just make sure to draw this. You can either try to copy and paste it, or you can draw it by hand and upload it. But these are examples of functions. Let's look at other examples of non-functions. So this right here is not a function because, like the shady bodega, right? This number 3 has two different outputs. It can either be a 2 or a 3, so it's not a function. Let's look at the table. The table is not a function because look at here. We have an x over here where we have two 1s. For one of the 1s, it's a 2, and the other one, it's a 5, right? Shady bodega, not a function. So a little trick that I tell my students is look for, when they're giving you asking you if it's a function or not, if you see any repeating x's, look to see that the outputs are the same. If they're different, not a function. And lastly is the vertical line test, which tells us that with the graph, if I draw a vertical line is a line that goes up and down, and notice that it's straight. If it only touches one point, it's a function. But if it touches 2 points like it does in this graph, here and here, or more, it's not a function. It's the same idea with the shady bodega, right? X, right? Like let's say the value here is 5. Well, here it has 1, and here it has 2. So the output could either be 1 or 2, you don't know which. So that's why we don't consider it a function. And that's all you have to do today, folks. You just have to fill out the Frayer model.